Okay, so we've transformed our data using Data Refinery and saved it into our project as HR employee attrition underbar shaped.csv. Let's take a look at the data and build, train, and evaluate the accuracy of several machine learning models at predicting if an employee is at risk of leaving the company. To get started, just head back to your dashboard in Watson Studio and create a new model. So here in our project dashboard under Assets, I can either go Add to Model or Add to Project Model, or scroll down under Project Assets and select New Model. So I'm going to go ahead and add to project and add a model to my project. And what this is a automatic model builder for Watson Studio. You don't need to transform the data into a particular format in order to input it into existing machine learning models such as random forest, linear regression. But to do that, we first need to create the Watson Machine Learning Service. To do that, we can just click here under New Watson Machine Learning Service. This is a free service, and click Create. And again, just accepting the defaults here. All right. I'm going to name my model Employee Attrition. I'll reload to pick up my machine learning service that I just created. And I'm going to use the model builder, and I'm going to use the manual model builder. And now this also depends on an Apache Spark service, but this is just as easy as creating as a machine learning service and as easy as creating as the Cloud Object Storage service. So I'll just click here on associating an Apache Spark service. Go ahead and accept the free light account version and confirm using all the defaults. Now I can connect this to existing Apache Spark servers that I have deployed on my own system or in other cloud environments. Okay, with that, I have a name, I have my machine learning service, I have my Spark service, so I'm going to go ahead and click Create to create using Watson's Machine Learning Automatic Model Builder to build a prediction model for employee attrition. And that's it. Now I need to select the data set. It automatically presents data sets that are in my project. So I'm going to select that shaped data set that we created earlier. Now it initializes the kernel, and it is loading our data. Here in a moment, it's going to ask me to select the features that we want to use when predicting if an employee is at risk of attrition, and then the label, attrition. Now, since when we looked at our data earlier in Data Refinery, it was obvious that we're trying to solve a binary classification problem. That is, you're either leaving the company, yes, or no, you're not leaving the company. So it's a 1 or a 0, a binary classification. Now I'm going to select the label column. Again, label is what we're trying to predict, attrition, and feature columns. Now you see that it selected every other column except for the label, and it's going to use those columns in building a prediction model for employee attrition. And that's it. I am selecting binary classification, selecting all the, it gives me the option to split the data into training, test, and holdout data. If you're unfamiliar, you don't want to test your model on the same data that you trained it with. When you're training a machine learning model, it iterating over and trying to find the best fit for what you're trying to predict using all the features. Now, if you go to test and evaluate your model with the same data you trained with, you're always going to see high accuracy. So we want to set aside some amount of test data that we do not use when training our model. But what type of model are we going to build? We can use logistic regression here, a decision tree classifier, random forest classifier, or a gradient boosted tree classifier. So I'm just going to go ahead and add all these estimators here and compare to see which one is the best. And that's it. So at this point, it is our Watson machine learning service is taking our input data, transforming the features into values that can be used as input to our machine learning algorithms, training to figure out what's the best fit for that particular best fit to make a prediction of if the employee is at risk of leaving the company or not. And then it is evaluating the model's performance against our test data. So as we see here, our first model that was trained was used linear regression, and this model was trained and evaluated with good performance. It had 81% accuracy. Now, since it's a binary classifier, anything 50% accuracy and lower anything lower than 50% accuracy is actually worse than random guessing. So our random forest classifier, our decision tree classifier actually ended up with a model that produced results worse than random guessing. Our gradient boosted tree classifier is training now. And at this point, we can look at the performance of our 4 machine learning models for predicting if an employee is at risk of leaving the company. I see that logistic regression performed the best, so I'm going to go ahead and save that model. And it's going to save that model into my project. And that's it. So here in just a few minutes, we've taken our data and we've built a machine learning model to predict if an employee is at risk of leaving the company or not. And we're saving that model into our project. In our next steps, we're going to take that model and we're going to deploy that as a web service and consume that web service. But until then, again, thanks for listening. I'm Justin McCoy, a developer advocate here at IBM, here to help you or your company jumpstart your next project in data science, machine learning, or deep learning. Let's build something.